Welcome back, one and all, to the 7th edition of Dev Days and DevOps. We are here ready to kick off day number 2. I'm, of course, Darren Elmy, your host and companion throughout the day. And we've got another special day brimmed full of the action. Remember, today, this year, is the first year that we've combined Dev Days Europe as well as DevOps Pro. So hopefully you guys are already seeing better bang for buck out of the information you're taking away from these sessions. And just a reminder that we do have a lot of sessions going on throughout the day. We open with the keynote speaker here, but there will be 28 thought-provoking sessions throughout the entire day, spanning across 5 different channels. So be sure to shop around and make sure that you're getting the best bang for buck for your brain. Now, before we get into the talks, I do have to give a big shout out to our sponsors. We have to express our gratitude to our gold sponsor, Pinup Tech, whose virtual booth will be available throughout the conference, and our knowledge partner, Packet, who, you know that you love this part, are offering you the opportunity to win stuff for free. And all you have to do is register as one of the most active participants here at the conference by rating on the sessions and leaving comments. That will give you a chance to win an ebook of your choice. Now, on top of that, we do have additional sponsors, but I'm not obligated to ring your ear about that. Instead, I just want to encourage you guys to keep an open mind. Make sure that you are not only engaging the topics with your ears, but also your mouth. It's a two-way process. You get what you reap out of these type of sessions. Now, it is time to kick off day number 2, and it is my pleasure to pass the microphone across to Rick, who is here to talk to something that we love to hear. It's like music to our ears. It's the word quality. He's here to talk to us about quality for DevOps teams. Take it away, Rick.
Okay, well, good morning, everybody. And I'm happy to see you all on this second day of the conference. And well, as you can see, my talk is Quality for DevOps Teams, based on the book that I wrote together with a couple of colleagues. And I'll be happy to inform you about it. And let's start with what are our challenges in IT delivery today. And the first thing is, business people don't ask for IT. They ask for business value. They don't care about IT. They just want value and also they want quality at speed. So they don't. To be able to do this, quality engineering is the responsibility of everybody involved. And therefore, QA and testing should be integrated in your process and in the people. And that's things that I'm going to elaborate on a lot during this talk. So the focus is organize high-performing cross-functional teams, like in DevOps. You build stuff and you make sure it keeps running and try to automate everything. And I always like to add, as long as it is useful, because the automation itself is not the goal. The goal is quality at speed. So it's all about value and speed. So I like to talk about high performance IT delivery, which covers things like Agile, Scrum, DevOps, etc. It's all under one umbrella, high performance IT delivery. And what is it? It's an approach that will teams continuously improve the products, processes, and people that are required to deliver value to the end users. And based on this statement, what is high performance IT delivery, I will take out the various elements and use that as my guide rail for this talk. So it's about high performance IT delivery. By the way, who am I? I'm a principal quality consultant for Sogeti in the Netherlands. And I started in IT when computers looked like this. It's more than 40 years ago. And one of the interesting things is technology has changed an awful lot since then, but the way we work actually didn't change that all that much. Actually, I was in an agile team in the 1980s. The only thing is, back then, we didn't know it would once be called an agile team. I do a lot of research and development on the IT profession, and especially on quality and testing. I'm part of Sogeti Labs, and I'm involved in other organizations like the Netherlands Association for Testing and the International Software Testing Qualifications Board. And doing research and development makes me possible to publish stuff like in books, talk about stuff like on this conference, and also help organizations in coaching and whatever to better deliver value and deliver quality. 5 years ago, together with my colleague Tom, we published Testing in the Digital Age, about testing of AI and testing with AI, which is still a very hot topic, and there's other talks on this conference about that. And some 5 years ago, I dove deep in DevOps, which led to our book Quality for DevOps Teams, which recently had the 3rd edition. Very happy ISTQB awarded me the Software Testing Excellence Award last year. So it's about high performance IT delivery, and the thing focuses mainly on Scrum and DevOps, but the agile mindset also applies to hybrid IT delivery models like the Scaled Agile framework. And when do we do hybrid? Well, mainly in large organizations where you cannot have just a team focus. You also need an overall focus. You need to organize for that. So I cover a little bit of that, but most of the talk will be about high performance delivery, and in particular DevOps, of course. So what is DevOps? Well, when we were thinking about what is DevOps, one of the things we did is we took the DevOps handbook written by Gene Kim, Jess Humble, Patrick Debois, and John Willis. And I don't know if you know this as a fun fact, but Patrick Debois, he is the guy who actually invented the word DevOps. Not that he was out to invent a new word, he just organized a conference for devs and ops people and just glued dev and ops together. And actually, we are quite proud by the fact that Patrick Debois wrote the foreword to our book, stating that quality is really important, even in DevOps. And DevOps is often depicted with this infinity symbol. And in the center, you see the activity monitor to keep an eye on what's happening on the dev side and on the ops side. Then, if there is a reason to change something, we have the plan activity, which is not just making plans, but also about requirements, designs, the things you want to make or to change. Then we have the code activity, which is, of course, about program code, but also about other things like infrastructure as code in a cloud environment, or even documentation as code. And then you need to integrate the stuff that we are creating with the existing stuff, because the cool thing of that is it takes a position that there will be IT always. There is something, there is an installed base, and the only thing we do is change the installed base and change maybe a small little change that we integrate with the existing stuff, or even completely replacing a system. It's still a change to the current situation. Then, of course, we have deploy, put it on the live environment, it keeps running, and then we're back at monitor again. And some people come to me and they say, hey, but you forgot, for example, about testing. And then, well, we didn't forget about testing and we didn't forget about quality. But where would you put testing? Do you do it after code? Probably unit testing, but also after integration, probably integration testing, user acceptance testing. And even we do testing during live operation, like A/B testing. And also we do testing in the plan activity, like reviewing documents. So that's all. And that is the cover of our book, which, by the way, I have a big banner here. You can see we have put the quality and testing around the DevOps activities. Now, as you probably know, DevOps has certain principles. These are the 6 principles from the DevOps handbook. And these principles nicely align with the Agile Manifesto, which is not a strange thing, because when we looked into a definition of DevOps, we found that there are quite a number of definitions. And, well, we took all of those and made a definition that really helped us to convey the message, and not only to IT people that generally know what DevOps is all about, but also to people like management who have barely heard of the term and don't know what it is. And then we tell them, okay, so DevOps is a cross-functional systems engineering culture. So DevOps is about the way people work together. And it is all founded on an agile mindset. So the Agile Manifesto fully applies. And I can't emphasize enough how valuable it is to once in a while visit the Agile Manifesto website to review what again Agile is meant to be. And most people implement DevOps with a Scrum framework. At least that's the case in the Netherlands where I'm from. Maybe you have others. One other upcoming way of implementing DevOps, by the way, is this. And I'll grab a book from my bookshelf. It is site reliability engineering. This is the DevOps approach that Google introduced. Google uses it to maintain their own website, the Google search engine. But they published a lot about it, also on the Google website, of course. And it's another it's growing in popularity, a way to implement DevOps. Anyway, so DevOps is a culture. It's a way of people working together. Then, as I said, quality and testing is all around in DevOps. In our book, we defined 20 topics, the quality engineering and testing topics, and these topics are related to the fundamental DevOps activities. And there's not a one-on-one relationship from one topic to one activity, because everything should be integrated together. So this picture just emphasizes that all these topics are relevant, and you should never forget one of these topics. However, some topics are you work on that every day, like let's say test design, test automation, test execution are things you probably work on every day. And other topics you work on only once or twice a year, like quality and test policy. A policy is typically a stable thing. You don't want to change it every week. So that's something you should not forget about, but it's not a day-to-day activity. Okay, so high-performance IT delivery is about cross-functional teams. What do we mean with a cross-functional teams? In our opinion, a cross-functional teams means we have several roles. And here you have a picture of a standard team with a business analyst, a developer, a tester, and an operations person. But this is not about functions. This is not about people doing nothing else than, for example, development. No, it is a cross-functional team. Everybody is allowed to pick up any task. So you can switch roles when necessary. And of course, one person is better on development, the other is better on operations, the other is better on testing. But suppose I'm testing, that's my background, so I'm testing something and I find there's a little problem there. And let's say a programmer mistyped something and there is a greater than symbol and it should be a less than symbol. I don't have to wait for a developer to make that change. That's a change I can do myself. So I switch roles. I switch a role to developer. I update the program and I run my test again to see if it now works properly. And then something important happens because the team takes joint responsibility for quality. So somebody else in the team checks my work. And that is what everybody does with everybody else's work. You know the principle of, come on, now the term escapes my mind in English. The pull requests, of course, pull request in your Git, for example. So a pull request mainly is asking another team member to review what you have done and make sure that the quality is good enough. So it's about cross-functional teams, and also it is about value, business value. And we thought that business value is so important that we actually created a new model for that. And we call this model the voice model. And in a minute, it will be clear why we call it the voice model. So it is all about business delivery. Yeah, IT is not the reason of our existence, although we may like it a lot, but the reason of our existence is a organization wants to deliver something to the world. And the first question is, what is the value they want to deliver? And then based on that, we get in the scope of IT delivery. And the first thing we do is determine the objectives. What objectives do we need to meet to get this business value? And when thinking about the objectives, we also need to focus on building quality in, and that is done by using quality measures. And I will come back to quality measures a lot later in this talk. Of course, when you know your objectives, you also want to know if you are reaching your objectives. So therefore, you define indicators. Not too many indicators, by the way, as I always say, somewhere between 1 hands full, so somewhere between 5 and 10 indicators, and you use them to measure if you are going towards your objectives. And measuring these indicators is mainly testing. So that's where testing comes in the picture again. And by testing, you supply information to your stakeholders, and that information is used, for example, by your product owner to support the confidence in the pursued value. So based on this information, they have confidence or not, of course, if the information is that the quality is bad. But let's hope we have good quality, so they have confidence they will get their business value and they decide to go live. And that's a team decision. Product owner is part of your team, of course, but you need to have the confidence that it will work. And then it gets in the scope of IT use. And then the users will experience the real value. And when they experience the real value, also they will get ideas for more value. And then we have value improvement loop. And this value improvement loop, if you do DevOps with a Kanban approach, you can deliver value multiple times per day. So you add a button or a message or whatever, you change little things and commit them, and you deploy them right away to your live environment. If you work in a Scrum approach with sprints of like 2 weeks, then your value improvement loop is every 2 weeks. And this voice model even applies in traditional IT, where it may be like a month or even longer. And by now you already probably figured out why we call it a voice model. It's simply the first letters of value, objectives, indicators, confidence, and experience. So business value is our starting point. And then it is about to continuously improve products, processes, and people. And these products, processes, and people, the 3 Ps I call them, is the backbone of making sure you have the right quality. And this backbone, I will use it throughout the remainder of my presentation to give answers for processes and for people. And here's another TRS. And now it looks like we had a glitch in the connection, but we're back again. So processes is about your DevOps quality engineering activities, and people is about skills and collaboration of the people. So that's basically the 3 Ps. So it is about quality engineering. Now we'll switch to the first Menti question, because I would like to have a little interaction with you. So switch screens and enter code 56938149. So you enter the code 56938149, and then you can put words in a word cloud, and that is about what words do you think of for the concept of quality engineering. Because what we found is that quality engineering to a lot of people is a new term. I must admit, the first time I heard this term is about 5 years ago. And back then, nobody could tell it what it really was. So on the next slide, I will show you our definition of quality engineering. But first, I would like to know what you think quality in engineering is all about. So go to menti.com, enter the code 56938149, and let's see what words you are thinking of. And now I'm hoping technology is helping us and it will work. I see people are putting the same in chat. Yeah, and I'm sorry that the video stutters. I understood of the technicians that they have been working yesterday to improve stuff. I have an 80 megabit connection, so it should be okay. And well, I see the first words coming in. Great. So professionalism, that's one I like. Reliability, testing, stable products. Shift left, yeah, that's also an important one. Pay attention to quality in an early stage. Care for things, deliberate, working together. Efficiency also, quality engineering contributes to that. Definitely. Automation, yeah. Maintainability is important. And what is that one? Intentional. Oh, yeah, of course. Yeah, you should indeed focus on quality. Well, of course, I don't know exactly how many people are online. I see already more than 50 things have coming in. Great. Well, you can remain entering stuff. I have another Menti question, so before we see that, we'll see the final result. But I'll switch back to my presentation now. Where is it? Yeah, that's this one. And let's see what is quality engineering. We define quality engineering as it is about team members and their stakeholders taking joint responsibility to continuously deliver IT systems with the right quality at the right moment to the business people and their customers. So I do see definitions once in a while that say the highest quality. But usually we don't want the highest possible quality. We want the right quality at the right moment. Because, of course, if you are writing software to send a spaceship to the moon, probably you want the highest possible quality. But the average organization really is better off with mediocre quality today than the highest possible quality next year. So it is all about the right level of quality at the right moment. Also, quality engineering is a principle of quality engineering, of software engineering, concerned with applying quality measures to assure the quality of IT systems. What is a quality measure? Now, first, I know a lot of you are not native English speakers. And the word measure in English is a confusing word because it means two different things. So you have to measure to see how long or heavy or big something is. That is the verb measure. And you have the word measure as a group of activities. And with quality measure, we mean a quality measure is a group of activities that is aimed at achieving a certain level of quality. So a quality measure is about things you do to get quality. Now, to make it more confusing, and after that, I hope you really understand, an example of a quality measure is testing. And what does testing do? Testing measures the quality. So testing is a quality measure that measures quality. I hope you still are with me. That is about the term. Okay, we have three groups of quality measures. And the first group is aimed at building quality in and doing things right first time. We also know those as preventive quality measures. They are to prevent problems in your IT system. But I like to take a positive view and say build quality in rather than the negative view of preventing problems. But it's basically the same. Now, of course, when people are working, people do make mistakes, so you must be sure to check whether you have the right quality, and if you don't, you can do something about it. And that is the realm of testing. So testing is to provide information about quality and risks, and we also call them detective quality measures. They detect problems, if any, but I always hope that I don't detect any problems with testing, because then I know that we have the right level of quality. And if you do detect problems, of course, you need to fix them. So we also have corrective quality measures, but it's not just about bug fixing. It's also about things like refactoring, proactive quality improvement. You see that you have something that's working and still you try to improve the quality a little better. So that is the groups of quality measures that there are. And then I will go some DVPs. So first, let's have an example of a quality measure for products. And an example, and by the way, if I say examples, you must know that we have made a list of over 100 different quality measures. So there's really an awful lot of choice. But an example is refinements. So what basically is a refinement? It's a preventive quality measure, and you can do refinements in a proper way by perspective-based reviewing. And we also call that the Four Amigos approach. Some people may wonder, Four Amigos, because it was called Three Amigos, isn't it? Well, Three Amigos is for agile, where you have the business analyst, the developer, and the tester. But with DevOps, of course, we also have the operations people. So the operations people are the fourth amigo. And in this Four Amigos approach, you make sure that from your team, you have four people representing these four roles. And then a general agile team would be 7 people. So it's about half the team, so save some time. And still you have different points of view in your perspective-based reviewing. And that makes sure that you have all the aspects that are relevant present in the documents you're reviewing. So this is a nice example of a quality measure. I already told all about that. The next example is how you align your quality measures with a risk level. And that is both preventive, detective, and even somewhat corrective. So here you also learn that a quality measure is not necessarily only preventive or only detective. It can be a mix. So what about the risk level? We want to build quality in from the start, but we also want to use the efforts and divide our efforts in such a way that it is most useful to the goal that we have. The goal is business value, remember? So the thing you do is you do a quality risk analysis. Some people know this as product risk analysis, but we like to emphasize that it is about quality risks. So the risks that and then you have a low risk. For example, you have one developer who creates some code and another does a review in your pull request, and that's a common way of working. But if you have high risk, you would like to have a higher level of quality, and that can be done by pair programming. So you have two people that together work on the code, and if one makes a typo, the other one spots it immediately, and you can fix it. And this is also an example of the so-called shift-left approach, because we want to build quality in as soon as possible. And we don't want to find this typo at the very end when you have to make a lot of steps back to fix it. So pair programming is very beneficial, especially in high-risk areas, because it may take a little more time in the beginning, but it saves a lot of bug fixing later. So this way, the effort of development of the product is aligned with the quality level needed to provide your business value. And of course, you can apply this to all tasks, because you can also do paired business analysis or paired testing. A nice example is exploratory testing, which is by definition done by two people. Okay, let's continue. What's my time? I'm still quite well on time. We even may have some time for Q&A at the end. If you have questions, you can already put them in the Q&A, by the way, and then the organization will forward them to me in my screen here backstage. So the next one is about processes. And an example of doing processes is using a software bill of material, which is both a preventive measure to build quality in, but also a corrective measure, because if there is a problem, you can use your software bill of material while you are fixing. And what is a software bill of material all about? It is about gathering all relevant information for your whole setup. So if there's something wrong, you can easily find it. And a lot of people in the world experienced the benefits of a software bill of material or the lack of a software bill of material during the Log4j problem, the security problem that we had like about a year ago, I think. And then some people had a proper software bill of material and easily could spot whether they used Log4j or not and fix it. And others had a hell of a job because they had to go through all of their software to find whether they used it or not. So I'm a strong advocate of using software bills of material as a foundation for everything you do. And some people amongst you will probably wonder, why is he saying that? Isn't this normal operations? Yes, it should be. But other people probably are now wondering, maybe I should have a look at what is a software bill of material. Well, I was talking about our book, but we also have a website, and all the knowledge from the book is also available on the website. It is tmap.net. I'll show the link later in my presentation. Another example of a quality measure, of course, is testing. And testing is basically detective. And you may wonder, what is testing? Now, I've been in quality and testing for 25 years already, and I've seen several definitions of testing. Today, we use this definition. The definition is, testing is verification, validation, and exploration activities. And now, let me explain what these are. And I'll explain them using my old calculator that is still on my desk. And let's suppose there is a design document for the calculator and it says 1 + 1 is 3. Now, obviously, that's a typo, so it's wrong. But the design document says 1 + 1 is 3. And if we do verification, we check whether things are built according to specification. So I get my calculator, I do 1 + 1. If the result is 3, verification passes. It is a pass because we have built what was designed. And I give you this simple, stupid example to make you aware that actually sometimes people do make mistakes and the mistakes do get implemented. So don't think that verification alone is good enough. You also need validation because any math teacher will tell you 1 + 1 is 2. So validation will say it's not fit for purpose, it's a fail, you have to fix it. But then comes exploration. Now, all of you who has played around with a calculator know that if you enter some numbers and you turn it upside down, you get some funny text. Well, I am sure nobody has ever written a design document stating you could make funny text with a calculator. It's something you find with exploration. And then you may think, yeah, well, this is a silly example, but now think about security. If you do security testing, verification would be, do we have a proper login ID? Do we have a password? Does the thing block if you enter the wrong password several times? So that's verification. Validation is more about fit for purpose security. So if I have a regular employee, they should have lower authorizations than a senior employee. So that's the fit for purpose part. And then exploration is where the ethical hackers come in and they try to get into the system without logging in. So, and that you find by exploration. You find how things can be wrongly used, maybe by accident, maybe on purpose. So therefore we say testing is verification, validation, and exploration to provide information about quality and the related risks. Well, we just looked at quality risks. To establish the level of confidence for your stakeholders that the test object will be able to deliver the pursued business value. So here you see a lot of the terms coming back that we saw earlier on. And a test object, that may be anything. It may be a small piece of code for your unit test. It may be an entire business process for your end-to-end regression test. So it may be all kinds of things that you test. Now, testing is divided in static testing and dynamic testing. And I think this is a very important thing to understand, because reviewing is a very powerful way to assure quality, because it takes much less effort to review stuff and then ensure the quality than to find all problems by dynamic testing. And even some things you will never find by dynamic testing. For example, dead code. So pieces of code that are never used will not show up in dynamic testing in running the system, but you can easily spot them with reviews. And reviews may be done manually, but they may also be done by tools, static analyzers. Also, you probably know regression testing. It's a term often heard, and it is about testing the unchanged parts of your application. So it is to see if while doing something, nobody kicked something else over. Because you all know if you change something here, it goes wrong there. So that's regression testing. And then people ask me, what is the opposite of regression testing? And actually, in literature, there didn't used to be a term for that. So what we did in our book, we introduced progression testing. And progression testing is about testing the new and changed stuff. And then also you may find problems get fixed. And therefore we have confirmation testing, also known as retesting. So these three together are the things you do when testing. And they are all three important. Now, basically testing has different stages, because a lot of people, when they talk about testing, only talk about test execution, running the dynamic tests. But it starts with a goal. Why are we testing? We want to achieve some pursued value. We want to cover some quality risks. We want to fulfill some requirements and some specification. Then we have test design, where we use test design techniques to create test situations that are translated into test cases using test data. And then we put them in test scenarios. And the test scenario is the list of test cases you want to execute. And often we do execute them automatically. And then we need test scripts to instruct the test tool how to run the test scenarios. And then we have test execution. So this is the fundamental process of testing and the elements that are in it. And keep in mind that don't just focus on running tests, but also carefully design them, because a well-designed test set may save you an awful lot of time. Because I have seen situations where people made thousands of test cases where we could easily achieve the same level of confidence with, let's say, hundreds of test cases, and that runs much faster. What is the most important part of a test case? It is the expected outcome. Because if you don't define your expected outcome up front, you may miss problems in the actual outcome, because sometimes things look okay, but they are not. So that's why you always need to define your expected outcome. So we are coming near the next Menti question. We are talking about code coverage. And code coverage is also a detective quality measure, because it's about testing and then measuring how much code you covered by testing. And then the next Menti question will show up. It is, what kind of code coverage do you use? And final the previous question, but now we'll switch to the next one, I hope. Come on. Why doesn't it progress? Oh, gosh. I've done something wrong here, I guess. Well, let's try it this way. Well, it worked. Sorry for the little glitch. I don't know what happened here, but so what type of code coverage do you use? It's the same code for Menti 5693. And unit testing actually is not code coverage. During unit testing, you measure your code coverage. So I hope other people have other examples of coverage. And of course, I don't want to give it away, so I don't want to give examples myself right now. So far, I only see one answer. Is there something going wrong? None. Well, if you don't use any code coverage, well, there's something to learn on my next. Now the things come in. Condition coverage, line coverage, class coverage. The Sonar tool, Sonar tool indeed can calculate your coverage. Still, answers are coming in quite slowly. And I don't have that much time left. You know what? You keep on typing. I'll switch back to this slide in a minute, but first go on with my talk. By the way, I now see also statement coverage coming in. So let's have a look. This is my presentation. Yeah. So code coverage. Often people claim to have 100% code coverage and they're very proud of it. And then I always challenge them because 100% code coverage in itself doesn't say very much. It is about the coverage type you achieved. And we have defined 5 types of coverage. And the first one is line coverage. And let's have a look. So if we have this piece of code, the piece of code is very simple. Read a variable called a. If a is larger than 10, we print yes. And it's an end if. That's all of the code we have. And now we want to cover this code. And to cover it, we have one test. And the test is with the value 5 for a. So we run the test. We do read a. It reads 5. It determines is 5 larger than 10? No, it's not. End if, end of the story. So we did not execute print yes. Now we had 100% line coverage. So line coverage because every line of code was covered. But I know developers who manage to get 5 statements on one line. And if you only execute one statement, you have 100% line coverage already. So therefore, the minimum level of coverage I think you should have is statement coverage. And to get statement coverage, we should use, and by the way, it says, so we have 100% line coverage, we have 75% statement coverage because we covered 3 out of 4, but we only covered 50% of the decision outcomes because we have 2 outcomes, yes and no, and we only covered the no outcome. So statement coverage at least covers every statement. So we could have done the same test with 20. And then if 20 less than more than 10, yes, it is, we print yes, and that's it. But it's better to do both. We test 5 and 20, and then we cover both sides of the decision, and we have both outcomes. By the way, maybe it's smarter to test 10 and 11 because these are the boundary values. Branch coverage, if you achieve 100%, is similar to decision coverage. There is a slight difference. And path coverage may achieve even a higher coverage because you may cover path combinations, especially in complex code. And then path coverage is used with the test design technique called algorithm test. Anyway, so that's about code coverage. And so the type of code coverage is what matters. And now we have a lot more. We also have method coverage, end-to-end testing, which is basically not code coverage, because in end-to-end testing, you want to test your business process as a whole, but don't try to achieve code coverage with an end-to-end test, because you would end up testing all kinds of exceptions, and that's not what you would like in an end-to-end test. So next I have to speed up a bit. Maybe I'll skip a bit if I really get in time trouble. So automate tests in your pipeline. And automating tests is both preventive and detective. So you want to have continuous feedback, and that is continuous testing is part of that. And we try to do tests as early as possible. That's what is the essence of Shift Left. So one of the things we do with Shift Left is test-driven development. Test-driven development is not about testing, it's about a development approach. But the development approach is to first think, how could I test this? That gives you a better insight of what you're actually trying to build. Also, it gives you test cases that you automate, and then you have an automated regression test for your code. And that is part of the continuous testing, which is all around your CI/CD in DevOps. So this picture shows you the importance of continuous testing. How do you implement that? Well, this is our standard picture of a CI/CD pipeline. We think in DevOps, pipeline is so important that we put this picture on the back cover of our book so that we always have it ready for reference. And in the pipeline, we have different stages. And of course, this is just a standard setup of a pipeline. Your pipeline will probably be more complex, but hopefully has the same elements. We have the build pipeline and the release pipeline. And at the end of the build pipeline, we have the team test stage. And in the team test stage, all of the testing by the individual team is done. And in the release pipeline, which usually is for multiple teams, if multiple teams work on one product, then everything comes together in your release pipeline. And that's where you have your business testing from a business perspective. And in the end, you put it in the live environment. Now, you probably know about the testing pyramid, which was first introduced by Mike Cohn. And the testing pyramid is about levels of automated testing. And that is that on unit level, you want small, quick running individual tests that are easy to check if your code is still okay. And that's the essence of test-driven development. Then we have integration testing, where you usually test APIs, you test connections between modules or systems, and you try to automate that on API level. And then a limited number of the automated testing is done through the GUI, and that's basically your business process testing, for example, in an end-to-end regression test. Now, some people say that you should always test. I disagree. You should always have some room for manual testing, and that's the little cloud on top of the pyramid. And that is about, for example, exploratory testing, because to get confidence, people also want to see that it actually works. Also, there are some things you can't detect with a tool, so you need people to have a look. And then another thing, and that's why we made this kind of picture of the pyramid, we added the left part of the pyramid, which is about the manual testing while creating the automated tests. Because automated tests are automation too. So you need to test them, and there's a lot of manual testing. And actually, if you have experience with building regression tests, you know that the majority of the problems you find with a regression test are found during the creation of the regression test, because then you are having a close look at the whole system and you find all kinds of problems. And after that, you hope your regression test never will spot a problem again, because the regression test tests the parts that were not changed. So it should not find any problems. Now, so my wisdom tile is It's seldom wise to automate nothing. It's never wise to automate everything. And please keep this in mind very well. This is my piece of wisdom about automation. Automation is good, but don't think you need to automate everything. And then we come to the people side. One of the things is proper code maintenance. And that's something that should be between the ears of people. Because usually when we start, we have very good clean code architecture and our code looks very nice. But then we start maintaining, and actually maintenance is roughly 70% of the lifespan of IT systems, and for some systems even much longer. So, and then we should aim for maintaining this clean code architecture. But what often happens in real life is this. People add all sorts of bolts and bulbs and things to the system, and then it becomes a problem. And you don't want that. So please, when fixing code, keep in mind that you always use the clean code architecture that you started off with. So prevent all these strange things coming out of your system and try to maintain your original clean code. And it takes a little bit more effort while fixing problems, but it saves an awful lot of technical debt later in later stages. Then Agile at scale. I already talked about Agile at scale very at the beginning. In our book and on our website, we use the Scaled Agile Framework as an example, but I know there are many other examples like LESS and Nexus and whatever. But the main thing in Agile at scale is you have multiple teams that need to collaborate one way or another. And what you need is to organize this collaboration. And for that, we have quality orchestration. Because you, of course, have your cross-functional teams, but you also have your Agile release train layer where you have multiple teams. You can have your large solution train where you have the end-to-end business solution that is supported by quite a number of teams. And you even have your entire organizations where you have the value streams, where you have portfolio management. And you need to orchestrate across all these levels because the communication between these levels can be a hell of a job. I know that because I'm currently consultant for a large government organization in the Netherlands, and this is our main challenge, this communication between all the layers. So therefore, you need a so-called end-to-end quality orchestrator, somebody who is responsible for the quality across all these teams, who takes care of the governance with, for example, the Scrum of Scrums. So it's not replacing a Scrum of Scrums, but it's supporting the Scrum of Scrums. And also it makes sure that the stakeholders have an end-to-end view. And this orchestrator can be part of a virtual team, or it may be a specific support team where the orchestrator has some team members, and even there may be specific end-to-end regression testing teams for this. And like I say on the slide, more can be found in the TMAP Organizing Built-in Quality at Scale training and certification. So it is about multiple teams. What you often see is in the CI/CD pipeline, one team has their own build pipeline, and they have the scope of one system, but they don't have the scope of the whole business process. So that's where in the business test stage, we will have the overall scope in the release pipeline, and that may be even a separate individual end-to-end testing team. And well, I already explained this. If we have multiple teams, they have their own build pipeline and they release to the release pipeline. So end-to-end testing, it's all about scope. And often people think of end-to-end testing as a simple chain of systems. But in reality, certainly you have several interacting systems. And actually, most of the time, it is a mesh of systems. And this is your real life end-to-end testing. And you don't probably want to test all of those. So you carefully need to think, what is the business process I test? And then my tip of today is if you want to do end-to-end testing, then start at the end. So you start to think at the end, what is my desired outcome? And then see how is this desired outcome triggered, and what kind of input do I need to put where in my match of systems to get my desired outcome. That this works much more effective than just throwing a lot of data to your system and see what comes out of it. So for an end-to-end test, starting at the end is really very important. So I'm coming to the wrap up, and then we'll even have a little time for Q&A, I hope. The goals are business value and quality at speed. You need to collaborate across the cross-functional teams, and you apply the several types of quality measures. And we have seen refinements and risk-based working. We have seen the software bill of materials, testing, code coverage, automated tests. And we have seen code maintenance and quality orchestration. And like I said, on teamapp.net, you have a download for the quality engineering strategy template, and that contains a page with over 100 quality measures. So we want to deliver business value. We use objectives to make sure we build quality in. We use indicators to supply information about quality and risks. That supports the confidence of the stakeholders so that we can experience the real business value. If you would like to know more, well, have a look at the book. It's available as electronic version or paper version. It's on icdbooks.com or in the bookstore. But as I said, you can also go just to the website. It's freely available to anyone in the world, and you can download nice things. You can find a lot of information. We also have TMAP certification scheme with exams provided by ISQI. And that brings me to the end and leaves some room for questions and answers. So are there any questions?
Hey guys, hey Rick, thank you for that really insightful talk. Guys, so Q&A, we have got a few questions. We'll get through one or two of them. Probably won't be able to get through all of them, so be sure to relay those messages to Rick. I'm sure he's willing to accept direct messages, just because I'm aware that we've got maybe 4 or 5 minutes before we need to get Rick across for his panel discussion in Hall 3. So I'll open up straight away. We got one coming in from Floor. She asks, what tooling do you recommend for creating SBOMs? Who should be primarily responsible for maintaining and or actioning the SBOM?
Well, there is quite a lot of tooling available for software bills of materials. And my first thing is start small. So don't think you need the most fancy tool around, but start small with just make sure you have version control in place, and then slowly it to product management, etc. But perhaps people failing massively because they try to implement a huge tool and then failed. So try to keep it small to start.
Okay. And we have one in from Radu. They ask, what do you think about go/no-go process for a deployment? Who should have the last word for a new release? In case all stages of the CI/CD pipeline are green, should we expect product manager/feature owner to approve the deployment? Did that come through? Or we might have connection. Are we back? Apologies to this, folks.
We are back.
Okay, fantastic. We're back.
So
I'm guessing you didn't hear
on the last slide, I
question.
showed my email address.
Mm-hmm.
What I propose, let's on the last slide, I showed my email address. I will also put the email address in the chat of this talk.
There you go.
And oh yeah, you now have it on screen. If people have other questions, feel free to reach out to me. I'll be happy to talk further with you. And also, like you said, right after this, we have a panel discussion. I'm also there. Maybe some of the things I talked about can be part of that. And so I propose we wrap it up for now.
Yeah, that's fully understandable. Apologies again, folks, for the tech issues. I was listening throughout, I think, bar one or two hiccups. We were able to hear most of the wonderful words coming out of Rick's mouth, clearly. Every once in a while, clearly, the robots got involved. I guess AI has taken over. But, Rick, for the most, we got the organic version of you. So thank you again for opening the day. We appreciate you. But I'm fully aware you've got a panel to get to, so we'll keep you no longer. Thank you.
Yeah, okay. It was my pleasure. Thanks you, and see you later.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh, we don't need to say we're sorry. We don't need to worship heaven's stars.